This lesson looks at the surface area of cones. You'll learn to find the lateral area of cones and find the surface area of cones. How is the lateral area of a cone used to cover teepees? Native American tribes on the Great Plains typically lived in teepees. Tent poles were arranged in a conical shape, and the animal skins were stretched over the frame for shelter. The top of a teepee was left open for smoke to escape. The shape of a teepee suggests a circular cone. Cones have the following characteristics. The base is a circle, and the vertex is point V. The axis is a segment with endpoints of the vertex in the center of the base. The segment that has the vertex as one endpoint and is perpendicular to the base is called the altitude of the cone. So once again, if the altitude is also the axis, we have a right cone just like we did with cylinders. And if that is not the case, it's called an oblique cone. The measure of any segment joining the vertex of a right cone to the edge of the circular base is called the slant height, and they're using a lowercase l for that. The measure of the altitude is the height, h, of the cone. And again, like cylinders, you can assume that cones are right circular cones. If it is oblique, it will be clearly stated. If a right circular cone has a lateral area of L square units and a slant height of lowercase l units and the radius of the base r, then lateral area equals pi r l. Now there's a development for that on the bottom of page 666 in your textbook, but I thought you guys would rather get right into problems rather than taking time to do that. A sugar cone has an altitude of 8 inches and a diameter of 2.5 inches. Find the lateral area of the cone. Well, first of all, I'd like to know what the radius is. And if I take 2.5 divided by 2, I get 1.25 inches. So I still have to find the slant height. Okay, they gave me the altitude is 8. So that's one leg of a right triangle, and we know the other leg is 1.25, so we can use Pythagorean theorem. So 5/4 squared, if we had that written as an improper fraction, would be 25/16 plus 8 squared is 64 equals c squared. So c squared equals 65 and 9/16. But when I go to take the square root of that, I'm going to have to round 8.1 is a nice place to round to. So I can plug that in, and all we have to do is use calculus and we're done. Rounding to the nearest tenth, I get 31.8, and my units were inches. And its area, so it's square inches. Okay, our next step will be to find the total surface area. Stated formally, if a right circular cone has a surface area of t square units and a slant height of l units, and the radius base is r units, then t equals pi r l plus pi r squared. If that sounds familiar, it should. It's like the surface area of a pyramid where we had t equals the lateral area plus the area of the base. And again, I like using SA for surface area instead of the t, but otherwise I'm being good. It said find the surface area of the cone around to the nearest tenth. They gave me the slant height and the radius. That's all I need. So I can just plug in. So pi times my radius is 1.4. My slant height is 3.2. Plus pi times 1.4 squared. Grab a calculator. And they said to round to the nearest tenth, so we're going to get 20.2, and our units were centimeters in its area, so it is squared. A cone is a solid with a circular base and a single vertex. The lateral area of a right cone is pi r l, where l is the slant height of the cone and r is the radius of the circular base.